made while we're testing. So the first thing take a look at just kind of the objectives. What we're trying to make sure is we know the two different types of errors that can happen when we run these hypothesis tests, how they're related to alpha, and then something that's called power. So let's say that somebody's on trial for committing murder. There are two possible hypotheses that the way that the judicial system works, the null hypothesis is that the person is innocent, and then the alternative to that is obviously that they are guilty. Those are the two things that could be argued by the lawyers. So once a jury reaches its verdict, we're not necessarily 100% sure that they made the right decision. We hope they did, but there's some mistakes they could make. Right? Now, if they send a guilty person to jail, that's a good thing. That's a great decision. If they set an innocent person free, there's no problem with that. However, let's say that they find the defendant guilty when they are innocent. Well, a, that's a problem, mainly because now all of a sudden they put um, the wrong person is in jail. Right? The other mistake is they could also find the defendant innocent when they are in fact guilty, and it's at this point that that the criminal is set free. So a murderer is walking the streets all of a sudden. So how this kind of ties back into what we've been doing, we'll start putting a name to it and look at it in context of what we've been trying to do. The two types of error. So a type 1 error is when we would reject the null when actually the null is true. So in other words, that's when we found the defendant guilty when they were in fact innocent. A type 2 error, we fail to reject the null when it is in fact false. So this scenario would be that we found the defendant innocent when they were actually guilty. That's the person walked. So another way to look at a type 1 error is reject the null when we shouldn't. We should have failed to reject it. And then another way to look at type 2, you fail to reject when we should have. So the real easy way to look at that is if we kind of know this table. So we have two decisions. We either reject HO or we fail to reject the null. Those are the two decisions we always make. Now, we're doing that, hopefully that we're going to make the right decision, but in actuality, there is some type of absolute truth. Either the null hypothesis is true or the alternative. The idea here, if we reject the null and it turns out that the alternative was true, that's good. Right? So in other words, if a guilty person is found guilty, that's good. Now, if we fail to reject the null and it just so happens that it is true, so they're innocent, we find them innocent, that's a good thing. The two errors fill the other two parts of the box. If we reject the null, despite it being true, that's a type 1 error, and then a type 2 slides down here. If we can know this box and how to read it and how to interpret it, that's going to make identifying errors really easy for us. So we'll take a look at this example. According to the U.S. Census Bureau, 10.2% of registered births were to teenage mothers. So we think that the true proportion is 0.102. Sociologists believe this percentage has increased. So there's our alternative. So a type 1 error, right? That means we reject HO when it is true. So in the context of this problem, if we reject the null, that means we're going to claim proportion of teenage, excuse me, write that, of teenage mothers is above 0.102 when in fact the original thought was true, when in fact the proportion is 0.102. A type 2 error, recall, is when we fail to reject HO when we should. So what does that look like in the context of this problem? That means that we would claim the proportion of teenage mothers if we fail to reject the null, that means we think that's true. So we're going to claim the proportion of teenage moms is 0.102, when in fact, when it actually is above 0.102. Right. Look through one more example real quick. So according to this association or whatever it is, they say the mean monthly cell phone bill is $49.94. So somebody thinks that that's different today. So here is mean. So this is a mean problem. I mean, someone thinks that it is different. So we just think that it is not $49.94. Right? So a type 1 error would mean that we claim, so we're going to reject the null when it was true. Right? That's a type 1 error. So in the context here, we would claim, so we reject the null, that means we think the alternative is true. So we claim average bill is not $49.94 when it actually is $49.94. Type 2 recall, that means we I'll write that. We fail to reject HO when we should have. Alright, that's type 2. So in the context of this problem, that means that we claim the average bill is $49.94 when in fact it is not. How we measure those mistakes, so the probability we make a type 1 error, so in other words, the probability we reject HO given that HO is true, that's equal to alpha. That's the same alpha level that we've been using throughout all of this hypothesis testing. Basically, when we're saying our significance level is 0.05, that means we're willing to make an error. We're willing to reject the null incorrectly 5% of the time. We're willing to make that mistake with that alpha level we set. The probability that we make a type 2 error, so the probability we fail to reject HO, given that HO is false, that's what's called your beta level. So these two things do sort of relate to each other. There's not like a magic, they add up to be a certain value or anything like that. One of the things to realize, as the significance decreases, so if you think about that, as we're willing, if we drop from alpha equals 0.05, if we drop down to 0.01, that means we're going to be it's going to be harder to reject the null at that point. So if it's harder to reject the null, right, this means harder to reject. So if it's harder to reject the null, that means we're more likely to fail to reject, which means the probability that we make that type 2 error increases. If you think about that for just a minute, it does make sense. Right? If we're less likely to reject, we're more likely to fail to reject. So we're more likely to make that type 2 error. The big thing to realize, The best way to reduce both types of errors is to increase sample size. The bigger the sample size, um, as I'm writing the same word over again, if we increase sample size, that's how we're going to reduce both errors. The more things we have in our sample, the less likely it is we get something strange. So one other way that you might see beta, so the probability that a test correctly rejects a false null, that's what's called power. And this is the other way that you might see beta get incorporated into any kind of problem. And so if you're asked what is the power of a test, you just take that given beta level and subtract it from 1.